All right, in this video we have 2.3 standard form quadratics. Now in the previous videos, 2.1 and 2.2, we hit vertex form and we really focus on those transformations. Now we're going to focus on a different method to graph. So your learning goal is very simple, to graph quadratics in standard form. Okay. Now up top here, f of x equals ax squared plus bx plus c. This is your standard form, okay? You're going to have your x squared, which is your highest degree, then your x, and then your constant. And there will be a coefficient in front of those most of the time, okay? Now, at any time you see anything missing, that just means that that a, b, or c value is blank, okay? Now, standard form is going to be really important going forward. There's a reason why they call it the standard form, right? You'll use it a lot in quadratic formula, and we see it this way, I would say, more than vertex form, okay? Now, to graph in this method, we're going to need something called the axis of symmetry, which is listed here. Now, the formula for the axis of symmetry is x is equal to negative b over 2a. Now, this b and this a, they come from the coefficients of standard form, okay? So to give an example, you might see something like this, 3x squared plus 2x plus 1. I just made those numbers up. That may not be a real quadratic. And we would go, oh, well, a is 3 and b is 2, c is 1. And we plug those appropriate numbers into the axis of symmetry. So negative b over 2a, you would go negative 2 over 2 times 3. And you would end up with x is equal to negative 1 over 3. Now, what is the axis of symmetry? The axis of symmetry is that line that splits your quadratic in half. You can see on the right here, it's like a little dashed line kind of going down right there. That's your axis of symmetry. It's like a mirror in the middle of your quadratic. It should look identical to the left and to the right of that axis of symmetry. And you can see those points are like reflected. So look, there's a point here, there's a point here. They're both 2 units away from the axis of symmetry. So if you find that, you kind of know exactly where it's being split into 2, okay? Now, because this axis of symmetry cuts right through your vertex, we can use that axis of symmetry to find the vertex because they share the same a value, or excuse me, share the same x value. Now, that's why I wrote the vertex like I did here. Looks super complicated, right? In vertex form, it was h comma k. Now you're seeing negative b over 2a, and then you're seeing f of negative b over 2a. So let's break that down. Because the axis of symmetry cuts right through the vertex, they have to share the same x value. So all we're saying is if you have this x value for the axis of symmetry, which you got from doing negative b over 2a, that is the same value there, okay? Now again, if you have an x value, right, and you need to find the y value, you would plug it in to the formula. You plug it into the standard form. So that's all we're saying here with this f of negative b over 2a is we're saying whatever that x value was from that axis of symmetry, plug it into your formula and get the y value. Now again, you see that pattern here for maximum or minimum point. It is the y value, right? Because your y value is either going to be the highest or the lowest point, which now we're going to be talking about as the maximum or the min, or you might even see like maxima or minima. Not really, I won't be really using it that way, okay? But that y value will be your maximum or your minimum point. How will you know is it max or min? And that's the orientation of your quadratic. If you look at it like this, and this first one, your lowest point is the y value of the vertex, right? If you look at it where it's reflected, that should be the highest point that I marked there. Your highest point is your y value. So this one would be the min, and that one would be the max, okay? So I hope you're seeing a lot of patterns here. Think about it, all right? Like if I were to just kind of erase everything on this page for a second, okay? If you need that stuff, go back. Look at this. Your x values is shared amongst your vertexes. Your y value is shared with your maximum and minimum. That's no accident, okay? So keep that in mind. Now, we have a couple problems that we're going to do, all right? The first step is if we're going to graph this in standard form, we need to find the axis of symmetry. But before we do that, we should label what our A, B, and C points were, okay? Now keep in mind, it needs to be highest degree to lowest degree to be standard form. The square, the 1, and then not having an x value. If this was out of order, if you saw 2x plus x squared plus 1, it needs to be put in order of x squared and then x and then your c, your constant, before you can do this. It's not in standard form if it's not written that way. Okay, so our a value here, we don't see anything, so it must be 1. Our b value, it's right in front of x, is 2. And our c value is 1. So because it was in that highest degree to lowest degree, I can just read left to right, okay? Then I go to my axis of symmetry. So x is equal to negative b over 2a, and I plug in my values. So negative b, because b is a positive 2, becomes a negative 2 over 2 times 1. Simplify further, we get negative 2 over 2, and then finally we get negative 1. So if I go to my graph right now, and I were to draw this line, which you don't have to draw, I just like to draw it, that is where my graph is going to, that's where my axis of symmetry, which we also call it the AOS. And so my parabola should be really centered on that axis of symmetry, okay? Now this also means I have half of the vertex already. I have the x value. How do I get the y? Plug it in, okay? So I go f of negative 1 equals negative 1 squared. Notice how it wasn't 1 squared and then applying the negative, because when you have the term x squared here, it's the whole thing being squared, okay? Plus 2 times negative 1 plus 1. Negative 1 squared is 1. 2 times negative 1 is minus 2 plus 1. So 1 minus 2 is negative 1. Negative 1 plus 1 is 0, okay? So our vertex is negative 1 comma 0. So I go to my graph, negative 1 comma 0 is right there, okay? So I know that A here is also positive. So I know that A is, or this is going up. So we can read the A in standard form, just like we could in vertex form when telling if it's going to be going up or if it's going to be going down, okay? So here we know A is positive, so it should be going up. But how do we find these other points? And that's where I listed pick 2 points, okay? And what I mean by that is pick 2 points to the left of x or to the right of x. So I can either pick 0 or 1, or I could pick negative 2 or negative 3. Because if you remember, you know, this 0 point here and this negative 2 point, they should have the same y value because they're reflected over the axis of symmetry. So why plug them both in? Why not just plug in one of those and reflect it to the other one? And the beauty of this is I can pick easier numbers. It's probably easier for me to plug in 0 than it is to plug in negative 2 and at the same time get the same number, right? So I'm going to pick, let me erase here, pick 0, I'm going to pick 1. I like those numbers better than negative 2 and negative 3, okay? And I'm going to plug them in. So let's do 0. F of 0 equals 0 squared plus 2 times 0 plus 1. Cancels. We get, you know, f of 0, equals 1, which means the point is 0, 1. So I'm going to go to my graph, and 0, 1 is going to be right here. In fact, let me change this color up. How about, yeah, I'm going to do the points in, now let's do the points in red. So that was your vertex, and that's your first point. Let me erase some of these arrows here. Okay. Now, again, this should be the same for negative 2. The same exact height, okay? Now, the next point, f of 1 equals 1 squared plus 2 times 1 plus 1. 1 squared is 1, 2 times 1 is 2, plus 1, we get 4. So 1, 4. All right, which now I reflected over for negative 3, and now I can start drawing my points like this. Okay, now the very last part there is that this maximum or minimum. This is just more of a simple question: is do we have a maximum or do we have a minimum? And the answer here is we would have a minimum, and that value would be 0. Okay. Now want you to start cluing on that maximum minimum, because when we get to those word problems, we always try to leverage that highest point. If you throw a rock up in the air, what's the height that it could get to? That sounds very difficult until you realize that the highest point is the y value of the vertex, which is not the hardest part to get. Okay. So this is a complete problem here. A lot of stuff going on. Okay. Let's do another one, but let's do one where there's an actual a value. Okay. So here we have f of x is equal to negative 2 x squared plus 8x minus 5. All right. And I'm going to do this one a little bit quicker. Identify right off the bat, they're in order. So a is negative 2, b is 8, c is negative 5. Okay. Now our axis of symmetry is x is equal to negative b over 2a. And I get negative 8 over 2 times negative 2. Okay. 2 times negative 2 is negative 4. So negative 8 over negative 4, I end up with just the number 2. So x is equal to 2. So that means I have the x value for my vertex, and I can go and plug that in. So f of 2 equals negative 2 times 2 squared plus 8 times 2 minus 5. This is where I see students make the biggest mistake. Okay. They think that, negative 2 times 2 is negative 4, and then I'm going to do negative 4 squared. But order of operations, this exponent, it comes before the multiplication. So I'm going to do 2 squared, which is 4, and then 4 times negative 2 is negative 8, plus 16 minus 5. So negative 8 plus 16 is 8. 8 minus 5 is 3. So we get 2, 3 as our vertex. So I'm going to go and I'm going to put these values, okay? Our axis of symmetry was positive 2. So I write that, this axis of symmetry so I can see where it's supposed to be. And then in green, I'll do my point. So 2, 3. This is where the vertex is, okay? Now, we need to pick 2 points to the right of that vertex and 2 points to the left. And I hope this point starts to help you see why we wait until we have the vertex. These 2 points to the right and left are different. I have 1 and 0, and I have 3 and 4 that we can pick from. And that's, again, pretty similar numbers to last time, except for what if my vertex was, 12, 15. That's going to be in a way different location. Okay, so I always try to wait till I know the vertex before I pick those points. But again, I see 0 and 1 is going to be easier than 3 and 4. So I'm going to pick 0 and 1. So f of 0 equals negative 2 times 0 squared plus 8 times 0 minus 5. That cancels because we're all multiplying by 0 there. And I'm left with negative 5. So f of 0 equals negative 5. So that's my point, 0, negative 5. Go to my graph, 0, negative 5, which is pretty, down there, which is okay. And we can see this is going down, which it should because a is negative. And then I'm going to go to my 4 point and plot that also. Okay. So notice how, look, 0 is 2 spaces away from the vertex. 4 is 2 spaces away from the vertex. So those points should match across the axis of symmetry. Okay. Let me just carve out a little bit of space here. Okay. Next one is f of 1 equals negative 2 times 1 squared plus 8 times 1 minus 5. 1 squared is 1 times negative 2 is negative 2. 8 times 1 is 8 minus 5. Negative 2 plus 8 is positive 6. 6 minus 5 is 1. So I end up with the point 1, 1. So I go over 1, 1 is here. And then so that means I should have 3, 1. I should have the same y value. And now I'm going to draw my quadratic or my parabola. Okay. And all of this is looking good. Okay. You can kind of see that stretch was applied again. Our a value here is really able to tell us a lot of the same things that our a value was in vertex form. It's, is it being reflected? Is it stretch or compression? A lot of the same details there. Okay. Now, again, wait, I did that right on this one. Yep, that was a minimum point. So here, maximum or minimum, we have a maximum point, which is up here, and that point is 3, or y is equal to 3. Okay. Now, what I should have done in the last problem was also talk about domain and range, just to make sure that we are constantly understanding those. The domain is all real numbers, and the range is y is less than or equal to 3, which again, notice that pattern. The highest value ended up being the number that you needed for range. Okay. All right. Let's go to one for you guys in a second, but I just want to talk really quickly about this again. Okay, very different from vertex form. And we're no longer really sitting there and graphing by the transformations anymore. We're really just diving right into it. Okay, so here's one for you guys to do, graphing in standard form. Give it a try, and then I'll show you how to do it. Okay, so hopefully you gave this a try. You can see off the bat it's in standard form. So A is -1, B is -2, C is -1. I use that for my axis of symmetry, -b over 2a. Now notice how B is a -2 up there, which means, if you plug it in, you end up with a negative, which will give you a positive. And then 2 times -1, 2 times -1 is -2, so I end up with a negative again, and my answer there would be -1. I have that for the vertex. I plug it in to get the y value. G of -1 equals, we have a negative on the outside again, -1 squared minus 2 times -1 minus 1. That's a lot there. Let me zoom in on that. Okay, so -1 squared is just 1, but then there's a negative on the outside, so it becomes a -1. -2 times -1 is +2 minus 1. Okay, so that all ends up being 0, right? Because -1 plus -1 is -2. -2 plus 2 is 0. So we get -1, 0, like that. Now I'm going to go and I'm going to put the axis of symmetry. Okay, and I'm going to put my point there. -1, 0. All right, for the vertex. Now I'm going to pick 2 points. Again, there's -2, -3 to the left. There's 0, 1 to the right. I'm going to pick 0 and 1 every single time if it's an option. Okay, so f of 0 equals -0 squared minus 2 times 0 minus 1. That cancels. You'll end up with the point 0, -1. So I go and plot that. That should be here, which it's going down. That's good. We see a -a value, so it should be going down. And then I reflect that point to be on this side. All right. Now, the next point is 1, right? So f of 1 equals negative times 1 squared minus 2 times 1 minus 1. Now, 1 squared is 1, but then we apply the negative. Okay. -2 times 1 is -2, minus 1. All these are negatives, so we could just add it up and call it a negative. We get -4. So we have 1 comma -4. Okay, so 1 comma -4. Sorry, let me do that in green. Like this. Okay. Now all this is looking good, right? It's going down, right? It's got it doesn't look stretched or compressed. It kind of looks like that parent function, but just going down and moved. All this is pretty spot on, all right? Now, do we have a maximum or minimum? We have a maximum point, and that is 0. Now, if we were to add in domain and range, we have a domain of all real numbers. And we have a range of y is less than or equal to 0. Okay, which again matches your maximum and minimum point. Okay, so hopefully you got that right. If not, try to ask some questions in class. Okay. All right, so I have some what ifs here. Okay, and the reason why I have some what ifs as what if something was missing? Okay, and this is gonna be the last thing that we cover, and it's very important. This is still a quadratic, okay? But you see a ton of missing pieces. So what do, right? Well, if you see missing pieces, you can assume that those missing pieces for, when I mean missing pieces, I mean, the B term, the C term, that they're 0. So if I were to identify this, A is 3, B is 0, and C is 0. So if I use the axis as symmetry, I get 0 over 3, which is just 0. Just because I have a missing piece does not mean I cannot do that problem. And then further, what if I had f of x equals 2x minus 3x squared plus 1? Well, I need to rearrange this, right? So I see that this is the A term, and then this is the B term, and this is the C term. So I'm going to put this one first and reorganize those. So f of x equals negative 3x squared plus 2x plus 1. Now it's in standard form. Now I can do it, okay? Now, and I know I have this vertex and height mark here, but I'm actually going to make another example. If I had something in vertex form like this, x plus 2 squared plus 1, there's no reason why I can't put that in standard form. If I have x plus 2 squared, that means I have x plus 2 times x plus 2 plus 1. And maybe you've seen this before, but then you can use FOIL. You multiply all the way across. So x times x is x squared plus 2x plus 2x plus 4 plus 1. Now I went through that really quickly. You may not see something like in this lesson, but I'm just trying to cover maybe any questions that you might have had. So we end up with x squared plus 4x plus 5. Boom. We went from vertex to standard form. Now we can use the standard form method. Totally fine. And there's even ways to go from standard to vertex. Now this last thing, vertex and height, we're really trying to focus on that maximum and that minimum point. If you have problems where I'm like, this stick figure was standing on this ledge and, they threw a rock up in the air and it modeled this path and they gave you an equation. They said that was, f of x equals negative 2x squared plus 3x plus 1, okay? I'm not even saying that would give the right path, but I'm just throwing an example. And then their question goes, well, what's the total height that the vertex, that the rock got to? And you're looking at all these details like, I don't know, he threw a rock off a cliff. What's the height of the cliff? What's, how far does the rock land? And you have all these questions, right? But then you just have to remember that the vertex is the highest point. So find the axis of symmetry, plug it in, you got the vertex, right? Use your tools for word problems. In this lesson you've been given standard form. You've been given axis of symmetry. You've been given vertex. We highlighted maximum and minimum. Use those to your advantage, okay? So I hope this what if section was nice. If you like it, please leave some feedback so I know if I should keep including those in the future. Have a great day. I'll see you guys next time.